G'day there everybody. Just wanted to do a really quick one to show you a replication of Slider's simple Wi-Fi electricity system. There is the YouTube video for those of you that wish to look up the original. It is very simple. I just watched it about an hour ago and I've replicated already. It's that simple. Most of that time I spent winding these two coils around this CD spindle here. I throw the clear one over the top. Make it nice and easy to wind. I'm using speaker wire. First thing I'd like to point out, like in sliders, there's some deviation from the Tesla pattern. It's by filler, but the two coils are sitting on top of each other. So one coil's on top and one coil's on the bottom. In Tesla's pattern, they have to alternate all the way coiling in. So that'd be one coil and the next one would be the other coil. Anyway, it seems to work alright like this. That's a 2N222 transistor and a AAA battery, and it's just hooked up like a regular jewel thief, and it works. It's great. It's the simplest, easiest Wi-Fi electricity I've ever seen. That's an AC detecting LED. You'll notice it's always the top one that lights up even when I turn the coil. If I don't have an AC one there and you do it the other way, you just have the one that's not lit up, it will light but not as brightly. These little orange LEDs I like a lot at the moment because they light up, they light up quite dimly from really low power, about 1.6 volts. And they'll take up to 60 milliamps and go quite bright too. That's probably half brightness there. But I don't know if you can see it on my hand. And something shiny. Pretty bright. For a little low powered orange diffused LED. So thank you, Slider. I'm loving this little circuit. It's a beauty. And for those of you that are interested, here is what the transmitter looks like on the scope. Now these are 10 volt divisions. There's a lot of power humming through that transmitting coil. We've got 20 volt peaks on our positive end of our coil, and we've got minus 11 volt peaks on our negative end. So that gives us 30 volts peak to peak total between the two ends of the coil, which I have hooked up to the base and the collector of the transistor, just like in a jewel thief. And it's probably not going to work with the LEDs soldered on there now, but we'll give it a go. Let's have a look. What sort of spikes? Not a lot. Yeah, having the LEDs on there kills it. There we go. If we drop the voltage divisions down a bit, you can see what's going on there. It's got a dodgy earth somewhere in this scope. I think it's been playing up a bit the last few days. You can see if I drop the receiver coil down to a half a volt divisions, you can see the waveform there quite nicely. Scale that time out a bit so you can see a couple. So there you have it. And this actually picks up power from quite a distance too. Help you see what I'm doing here. I'm pretty impressed with the transmission range. For the low input power. And over the next day or so I will try and get some power in and power out figures for you guys. It is a bit tricky with these high pulsing Wi-Fi systems because it messes with all the measuring equipment. But I'll see what I can do and I'll post another video soon. Thanks for watching.